Hey everyone, I hope you're enjoying your day. Let's get it. So we left our lecture talking about soil. Love soil so much. Um, and another part of learning about soil is learning about what we call the soil horizons or a soil's profile. So become familiar with that vocabulary there. Here is a common diagram that you would see. And I like to remember the layers um, like this: the O to the A to the E to the B to the C to the R. I don't know if that's going to work for you, but say it like 10 times in your head and it kind of sounds like a rap. So the O to the A to the E to the B to the C to the R. So O, A, E, B, C, R. And that's the way it goes from top down to the bottom. So what does that O layer stand for? That's the organic layer. So that's where it's going to contain a lot of the humus. Humus is organic material. So that is the very top. And so that's where the grass are. That's where the grass is, where there's basically trees or any living things. That's going to be that O layer. And any dead things. If something just died right on top, that would also be considered part of a humus, like some leaves that fell on the floor or something like that. Now, directly beneath that is now where we're going to get to that dark material. Like if I dug something down, and when I say dark, I mean in good areas. That's going to be your topsoil. That's the A layer. Okay, so with the first layer is the O layer, tippity top. It doesn't really look like soil because there's grass particles, tree particles, dead squirrels, things that are constantly decomposing. And then once you get into some real dirt or soil, that dark material, that's going to be called topsoil. All right. Now, topsoil is going to be the most nutritious of all the other soils or beneath that. Of course, we could say the organic layer could have more nutrients as well, but typically they're not even broken down yet. They're just still in their organic state, not decomposed yet. But that topsoil, that's like fast forward, it has decomposed. It's typically dark in color if it's rich in organic material. Rich in what? NPK. All right. Nitrogen, phosphorus, and potassium. So if you went to Home Depot or Lowe's or any type of landscaping place right now, and you wanted to make the planter's box a little bit more fertile in your area, what you would do is you would get some topsoil, and you could buy that. I think it's from $3 to maybe $6 a pound, a bag, and a bag could go from 25 pounds to 50 pounds, so depending on where you're going. You could grab that. And our planter boxes, typically what I did in our courtyard is I brought maybe 20 over the years, 20, 40 bags of topsoil and dumped them in. Also used some topsoil in my backyard when I was doing my own garden as well. All right. So the O, organic layer humus, then our topsoil. Then we have the E, and some diagrams are more complex than others. And so you may not see the E in some, and you'll go right into the B and the C and the R. But I'm going to teach you, of course, the most important things. And the E layer is going to be the zone of eluviation. Say that, eluviation. What does that mean? Also known as the zone of leaching. So if we take all three of these, OAE, that is the zone of leaching. And you got to become familiar with this word leach. Leach or leachate is basically mean when water goes through something, it's going to pull with it like some of the nutrients, or if this was garbage, it's going to push some of the garbage down. So it's like drainage of nasty stuff or drainage of good nutrients and stuff like that. So the zone of leaching, let's imagine if it rains and let's say there was a dead squirrel on top and it's decomposing, the rain is going to hit the squirrel. The squirrel juice, squirrel juice, the squirrel juice is going to start percolating through the ground because the ground is permeable, because it has porosity. And this would account for the zone of leaching. All right, so the O, the A, the E. And then where those nutrients are eventually going to sit because they can't penetrate any deeper anymore is what we call the zone of accumulation. So think about that. This whole area here is the zone of accumulation. All right. We also have the letter B here because this could also be known as the subsoil. So we have O, organic layer, topsoil, subsoil, okay, weathered rock, and then complete rock down here. The zone of leaching is going to basically include the O, the A, and E. That's where most of the nutrients are going to percolate through the ground. Those nutrients are going to accumulate in the zone of accumulation. Now, it's so amazing, and let me tell you why. Because where do roots grow? Roots grow down. And why do they grow down? Well, they're trying to get to the zone of accumulation. The zone of accumulation is where all of the nutrients have accumulated from the decomposing organic material that's on top. Also, water. Water is going to percolate through the ground, eventually going to the cracks and crevices of the weathered rock. And so roots penetrate deep to get moisture and nutrients. This is the beauty of soil horizons or soil profiles. Depending on where you are, and I know we spoke about grasslands before, you can have a very large topsoil layer, or you can have a very small topsoil layer. Ideally, you want a very large topsoil level. And unfortunately, here in Jersey, because our soil is relatively new in comparison to the Midwest, our soil is not very deep. Our soil is probably about 10 inches. And you could see that when we go down to Merrill Park, or if you go down to Merrill Park and you look at the stream is literally a cutout of dirt. It's like someone just dug a huge hole. You look at the side of the stream, you'll see boulders. That's going to be the bedrock. You'll see the weathered rock. You keep going up, you'll see a large zone of accumulation, and then you'll just see about 10 inches of topsoil where all the trees are basically growing through there. So it's really quite a vision when we go down there. All right, let's continue. I always get tripped up trying to change the slide here. Oh, I want to click happy. Oh boy, look at us. We are all screwed up now. Welcome back. Sorry about that. So more on soils. I apologize for the noises. The babysitter had a death in the family, and our little angel is here running around causing us some hazards. It's all right. We love her anyway. Now, like I was saying before, certain biomes have a very rich, thick layer of topsoil, and that would be the grasslands, temperate grasslands specifically. That's why we grow all of our crops there. Remember how we were talking about tropical rainforest. On the other hand, they do not have a very thick topsoil level. So tropical rainforests are really in danger of turning into deserts quite quickly, because if there's a lot of rain, the remaining topsoil would basically get washed away if the vegetation was removed. And a lot of times, the populations around the equator are growing very rapidly. I'll give you an example in Brazil. And so the tropical rainforest is cut down, the Amazon, for crops. And then since the soils aren't very, very rich, 2 or 3 years later, the topsoil is spent, and therefore they have to burn down more of the forest to continue with the food supply because of the population growth that is occurring there. All right. So another just fun fact: beaches have no topsoil. Right? They're just sand, which would be weathered rock. All right. This is a pretty sad image here. And, well, you know, I guess it's you're darned if you do, you're darned if you don't. We need trees. I'm not going to say we don't. And in this area, if you're going to do it, did they do it right? I guess they kind of did it right, but it's still sad to see. So what I'm looking at is they went into the middle of the forest and they took some trees and then they left. And it's fragmenting this area. However, they didn't destroy the whole thing where they took all the trees. So I could see that this area is going to go through secondary succession, and that'll happen quite quickly. All right. Not saying this is a good thing or a bad thing. Imagine you were a tiger and all of a sudden that was your hunting grounds, and Now that's shrunk. But at the same time, let's be realistic. We need resources. So I do like the fact that they left the surrounding foliage. So the baby pine trees, these woodland pine trees, are going to, um, go back in that area relatively quickly, as opposed to, killing all the trees and then leaving that area. But when soil is exposed like this, it quickly can be lost to wind and water erosion. So I love to see a cover crop in our little courtyard. I was showing the students that came in. There's some weeds that are just taking over, and weeds will take over. What is a weed? A weed is basically any type of plant that you don't want to grow. So maybe another step that we can do to try to reduce soil erosion is plant some type of cover crop in this region before we leave. And a lot of times when in America, I could say, when we do cut down trees, we've already started some baby trees in another area, and we'll replant these baby trees right afterwards. So we know we need these trees. It's not like we're just going to keep cutting and not replanting. But if we are going to remove, we need to basically replant quickly afterwards to make sure that soil stays in place. Because if that soil goes into the ocean, there's pretty much no return from there. And we definitely need our topsoil. It's not something that just grows like that. It takes a long time to make soil. All right. So sad that this happens. What can we do to remedy the situation? Because there's certain things that you could remedy, and replanting, maybe fast growing type of crops would be something that you could look into to reduce the amount of soil erosion that would occur. All right. Now, let's think of soil as an ecological service function. Okay, soil grows food, so it provides sustenance for us. It cleans water. As water penetrates through, it's going to absorb a lot of that pollution, and it gives us so many different resources. There are too many to even think of. So every type of food product is basically going to have some origination from soil. Even like, beef or poultry, they eat something, right? They eat grass, or they're going to eat something that's going to start on the first trophic level. And that first trophic level is necessary to create the soil. So please protect our soil. I love this soil. Quick fun fact, you see these beautiful red worms here. And back in the day, Viterra used to have something called a vermicomposter. And a composter in general is basically a term used to describe allowing things to rot. I've experimented a little bit with this. And you can get a container. The container should be porous, so it should allow water to percolate through, but water should also get in. Moisture is important for the decomposition process. Then you would throw in, let's say, banana peels, the eggshells, old broccoli, old lettuce, spoiled vegetables. You could throw them all in here. Throw in some of your local dirt and allow nature to take its course. Now, if you stuck to those things, vegetables, complete vegetables, eggshells only, not the egg, no pasta, no rice, no bones, no meat, no fish, then your compost will not smell. And you could have it relatively close to your house. Now, a lot of times people in farms have these compost piles, and it doesn't matter what you put in it because it's going to generate a lot of smell. Can you imagine a dead body or a dead carcass? It's going to put up a lot of odor. That odor will attract other animals, and you're going to have a big old mess if you have it closer to your house. But if you want to do a compost, I even had the compost in my garage. It was just vegetative matter. And this is a way to reduce your ecological footprint. But one of the things that could really help the process is these red worms over here, these red wiggler worms. And I've read somewhere where they can eat up to their body weight in a day, which is crazy when you think about that. So I'm 220 pounds. Can you imagine me eating 220 pounds of food in a day? Well, these worms can eat their body weight in a day. And what do worms really eat? So worms eat the fungus that is eating everything. So if you died right now, and your body started to decompose, they'd probably start turning very soft and white and mushy. And that mushy substance is what these worms could slurp up and eat. So it's a beautiful mutualistic relationship that exists in nature. And the worms also provide holes in the dirt, which allow gas exchange. So there's going to be a lot of gas exchange that occurs, and that's going to allow the microbes and more fungi to decompose even faster. And so, can you think about it? Can you imagine these worms creating these little holes, making the decomposition process happen even faster and faster? All right, let's try to change this really quick. And we're done with soils, and we're on to atmosphere. So let's do about two more slides, and then we'll call it a day for today. All right. So we have, depending on what book you're going to look at, you may see 4 layers, you may see 8 layers. But basically, there's 4 layers in our atmosphere. Our atmosphere is the gas area that exists in our nature. Okay? So the first layer, and you're going to need to know these in order, is the troposphere. It's probably the most important one. Okay? The second most important is the stratosphere. Second most important. We'll go over why in a second. Then we have our mesosphere and a thermosphere. So let's look at it here. Troposphere is that first one. This is the one we live in. Look a little by Terry. That's basically right there. Okay, the tallest mountains are in the troposphere. Okay? That's the Everglades, the Rockies, the Himalayas. All of our weather occurs in the troposphere. All the clouds, all the weather. So the troposphere is pretty um, full, if you will. And that's why I say it's the most important because we live in it, because the weather occurs in it. That's why it's really important. Okay. Also, really fun fact is that the greenhouse effect, okay, that's a layer of gases. The greenhouse effect, or the greenhouse gases, so that's GHG, sometimes abbreviated as GHG, are all in the troposphere. Sometimes it goes troposphere, tropopause, stratosphere, stratopause, mesosphere, mesopause, thermosphere, thermopause. But just understand that that's basically 4 different layers. Now, I hope you saw that movie Iron Man. Iron Man, when Iron Man's getting beat up, I think the original one, and he decides to do the super move where he's going to fly straight up into the sky. It's so weird. As he flies straight up into the sky, he gets to a point where he starts to freeze. Why is that? Well, it's kind of weird. Okay, it's kind of weird. But as you go higher up in the atmosphere, it gets colder. So if you ever imagined why is there like snow on the Everglades, well, you're higher in the troposphere, so therefore it gets colder. Okay, and that's something. So when we look at this diagram here, we're noticing that the temperature changes this way. What's weird is that as we enter the stratosphere, it actually goes the opposite way. So it actually gets warmer. Now, the stratosphere is only important because it has the ozone layer. So there's the big difference between those two. One has the greenhouse layer, the troposphere, and the stratosphere is going to have the ozone layer. Let's not get confused with those 2 layers. This is a common misconception. And people get these 2 things mixed up all the time. They're 2 separate entities. They don't, ozone typically doesn't necessarily affect temperature. Okay. And we could debate this and go on in detail with this. Right? Greenhouse gases affect temperature, not ozone. Some people think that the ozone is basically becoming depleted, therefore allowing more sunlight to get in. That's why the Earth is warmer. No, you are not there. That is incorrect. All right. The greenhouse layer of gases are getting bigger and bigger. Therefore, sunlight is getting insulated more and more. Less of the sunlight is able to escape. So, therefore, the Earth is getting warmer. That's the greenhouse effect, not ozone depletion. 2 separate environmental topics, which we'll go over. I digress. So now it gets warmer as you go into the stratosphere, and then it goes colder in the mesosphere, and then it gets hotter again in the thermosphere. Why does this happen? You want to think about the way light energy reacts when it hits different substances. I could say perhaps in the troposphere, the Earth is still warm. So therefore, the closer you are to the Earth, it's warm. As you go to outer space, you're getting colder and colder. And the stratosphere, different layer of gases that behave differently when the solar radiation hits it. And then similar to the mesosphere, and finally, you're getting closer to the sun, so it's starting to get hotter. All right. The thermosphere is also known as the ionosphere as well. You guys are amazing. You did a great job today, and I'll talk to you soon.